So here my question is, suppose you are given a function f of x equals to x to the power 13 plus x to the power 11 plus x to the power 9 plus x to the power 7 plus x to the power 5 plus x to the power 3 plus x plus 19. This is the function f of x, right? Now the options are, now fx, this function fx has roots, fx has real roots, right? Fx has real root. Option 1, fx has real roots. Option 1, 2. Option 2, 3. Option 3, at most 1, and the option 4 is it will be subscript, right? So actually we are going to find out how many real roots are there in this function f of x. So before starting this problem, we should have some idea about the solution. What do you mean by the solution? Solution means the function y equals to fx. The function y equals to fx, actually I am finding those points where this graph y equals to fx cut the x-axis. Suppose this is our graph, right? Now if this is y equals to fx and this is our x-axis, then these points will be the solutions. So where the graph y equals to fx cut the x-axis will be the solution of this equation f of x equals to this. Now let's find out the possibility where the graph cut this x-axis. First of all, look at the property of the function. This function, I am going to prove that the function will be monotonically increasing function, right? Why it is monotonically increasing? So let's find out its derivative, f prime x. So f prime x equals to 13x to the power 12 plus 11x to the power 10 plus 9x to the power 8 plus 7x to the power 6 plus 5x to the power 4 plus 3x square plus 1. Now look at this function, this derived function f prime x. This function always give the value which greater than 0. And we all know that if for a function f of x, f prime is greater than 0 for all value of x, then the function will be monotonically increasing function. Therefore this is monotonically increasing function, MI function, right? This is monotonically increasing function. Now the property of this function is, if a function is monotonically increasing, then this function cut this x-axis. Suppose this is x and this is y-axis. If this is monotonically increasing function, then this function f of x, this function cut this x-axis at most one point, right? At most one point. So here, since this function y equals to fx, this is monotonically increasing function, and so this function cut this x-axis at most one point. And since our given polynomial, this is actually a polynomial, so since our given polynomial is an odd degree polynomial, therefore this has a possibility, this has one real root, right? This polynomial should have one real root, because if there is complex root, then it will be actually pair format. Suppose z is the root of this z equals to, suppose x plus iy is the root of this equation, then its complex conjugate will be also the root. So actually the complex root occurs in pair format, right? So that's why, since this is the equation with odd degree 13, odd number, so it has a real root. So that's why the right option will be at most one real root. So this equation has real root, at most 1, right? Not 2, 3, 4. Since this is increasing function, this must cut this at most 1 point.